Hello everyone, welcome to Math Major Minor. Today we'll be looking on SAT Complex Numbers Part 2. So the complex number consists of all sums a plus bi, where a and b are real numbers and I is the imaginary unit. The real part is a and the imaginary part is bi. So this is how a complex number actually looks. So let's look at some SAT questions from the College Board exam. Now, this is similar to algebra where we add like terms. So 7 plus -8, which is the real component, plus 3i plus 9i, which are our imaginary components. Now 7 plus -8, that's -1. And 3i plus 9i, that's going to be 12i. So A is our answer here. Now let's look at another example. It says, what is the sum of the complex numbers 2 plus 3i and 4 plus 8i? Again, we add the like terms, which would be adding 2 plus 4, which are our real components, and 3i plus 8i. That will be 6 plus 11i. So C is our choice for this question. Now, the SAT way. Now, on the SAT exam, it's always good to look at the answers first. So if we look at choice A, B, C, or D, we notice that none of the real components are the same. Similarly, none of the imaginary components are the same. So if I were to go and add 2 and 4, that's going to be 6, which means C would be my only logical choice. And I wouldn't have to go any further. Remember, on the SAT exam, you're only allowed 75 seconds per question. Now, let's look at this example here. Which of the following complex numbers is equal to 5 plus 12i minus 9i squared minus 6i? So if we recall in our previous video, I squared is equal to -1. So let's rewrite this as 5 plus 12i minus, open bracket, 9. And we know that I squared is -1. So let's put this as -9 minus 6i. What we can do here is to expand our brackets. It should be an I right here. Let me fix that up. So this is going to be a negative times a -9, which is a +9. And a negative times a 6, -6 is a +6. So 5 plus 9, that's 14. And 12i plus 6i, that of course is 18i. And choice D will be your answer for this question. Now remember, the SAT exam is all about speed and accuracy. Now, let's look at the real components of each of these answers. None of these are the same. Similarly, none of the imaginary components are the same. So what if I went and I added 12i minus -6i? That would be 12i plus 6i, which would be 18i, and that's my only logical choice. And that's the SAT way. Remember, it's all about speed and efficiency. Now let's look at conjugates. The conjugate of a plus bi is a minus bi. And the conjugate of a minus bi is a plus bi. Now, why do we need conjugates? Now, conjugates are useful in dividing complex numbers. Now, what is the conjugate of 3 plus 4i? Now, you could pause the video and try it, and we'll see what you get. Okay, so the conjugate of 3 plus 4i, that would be 3 minus 4i. So what we simply do, we find the additive inverse of the imaginary part of our complex number. So we do not change the real part, we change the sign of the imaginary part. Now, what about the conjugate of negative 4 minus 7i? The real component is negative 4, the imaginary component is negative 7. So I keep the negative 4, but I change the sign of the negative 7, and that becomes a positive 7i. What about 5i? Now, does 5i have a real component? No, but it has an imaginary component. So we do take the sign of our imaginary component, which would be negative 5i. So we change the sign of positive 5i to negative 5i. And what about 6? Now, does 6 have an imaginary component? No, which means the conjugate of 6 is still just 6. And let's see why. Of course, 6 plus 0i is the same thing as 6 minus 0i. So the conjugate of 6 is 6. The conjugate of a real number is still a real number. Now, how do we calculate the product of two complex numbers? Now, let's see. So in algebra, we could FOIL by multiplying the first by the outer, the inner, and the last. So we could multiply the first two, the outer, the inner, and the last. So let's go with the first. 4 times 4 here, that's going to be 16. Then 4 times negative 3i, that's negative 12i. Then 3i times 4, that's going to be positive 12i. And then 3i times negative 3i, that's negative 9i squared. Now, clearly, the middle terms here would cancel each other. So we're left with 16 minus 9i squared. Now, remember, I squared is negative 1. So this will be negative of negative 9, which would be 16 plus 9, which is 25. Now, the SAT way. Now, we could recall a plus b times a minus b as a squared equals b squared, which is a difference of two squares. So what do you think 4 plus 3i times 4 minus 3i would be? So you could give it a try. Okay, guys, so let's start by multiplying 4 plus 3i times 4 minus 3i. We will start by squaring the first term. 4 squared, that's 16, minus the second term squared, that will be 9i squared. Now, 16 minus, we know that I squared is negative 1, so that'll be negative 9. And 16 minus negative 9 is 16 plus 9, which is 25. Again, let's square the first term. 2 squared, that's 4, minus, and 5i squared, it'll be 25i squared. So that's 4 minus negative 25, and that'll be 4 plus 25, which is 29. Now, I'm going to give you the chance to try this one for yourselves. So you could pause the video and we'll go right back at it. Now let's see what our answer will be. So 1 squared, that's 1, minus I squared, which would be 1 minus negative 1, and 1 minus negative 1 is actually 1 plus 1, which is 2. Now, this is how we multiply or how we multiply a complex number by its conjugate. Now, why do we need to multiply a complex number by its conjugate? We need this in order for us to divide complex numbers. So let's look at dividing complex numbers. If I were asked to divide 3 plus 2i by 4 minus 3i, the first thing I'd need to do is to multiply both the numerator and the denominator by the conjugate of the denominator. Now, the denominator here is 4 minus 3i, so my conjugate is 4 plus 3i over 4 plus 3i. Now, I multiply top and bottom to keep the same value of my fraction. So whatever I do to the top, I must do to the bottom as well. Okay, so let's go ahead and FOIL my numerator. So 3 times 4, that'll be 12. And 3 times 3i, that's 9i. 2 times 2i times 4, that's 8i. And 2i times 3i, that's 6i squared. Now, for my denominator, remember, this is a difference of 2 squares. So that will be 16 minus negative 9. So here, let's do some simplification. We know that 6i squared is negative 6. So that's 12 minus 6. And 9i plus 8i is 17i. And that's all over 25. Let's simplify it. So 12 minus 6, that's 6, plus 17i over 25. And guys, we must write this as a complex number written in the form of a plus bi, where the real part must be clearly shown and the complex part must be clearly shown. So I write this as 2 separate denominators or 2 separate fractions. And this is my final answer. Now let's take a look on a complex number question from the SAT paper. Now we have 8 minus I divided by 3 minus 2i. If the expression above is rewritten in the form a plus bi, which is our complex number form, where a and b are real numbers, what is the value of a? So they only need the value of my real part. We need to decide which conjugate will we be using. Is it the conjugate of the numerator or the conjugate of the denominator? Now, in all cases, it's always the conjugate of the denominator that we use. Now, what is the conjugate of 3 minus 2i? My conjugate is 3 plus 2i. And we need to multiply both our numerator and denominator by 3 plus 2i. So let's go. We're going to FOIL this. So that would be 8 times 3, that's 24. 8 times 2i, that's 16i. Negative I times 3, that's negative 3i. And negative I times 2i, that will be negative 2i squared. And this is all over. And by now, we should be used to this. That's going to be 9 plus 4. This is a difference of 2 squares. So let's go below here. Now, this will be 24, and this is minus 2 times negative 1. So that's 24 plus 2. Plus 16i minus 3i, that's 13i, and this is all over 13. 24 plus 2, that's 26, plus 13i over 13. If we split this, that will be 26 over 13, plus 13i over 13, which is 2 plus I. So my real component is 2. And that's going to be my answer. Now, that didn't take us 75 seconds. It might have taken us some more time. So what we're going to do is to do it the SAT way. So we're gonna multiply by our conjugate quickly, which is 3 plus 2i over 3 minus 2i, 3 minus 2i. So working out our numerator, we get the same as before. So that's 24 plus 16i minus 3i. And of course, minus I times 2i, that's going to give us a positive 2. My denominator is 9 plus 4. Now, we're only concerned about the value of a. The value of a would be 24 plus 2 over 13, which is 26 over 13, and that's clearly going to be 2. So using this method, we won't need to simplify this as far as we need to go. Remember, on the SAT paper, we only have 75 seconds per question. Now, here we have our final answer for the day, which is, of course, an SAT passed question. Now, instead of me showing you how to work the whole thing out, I will show you how to get the answer as quickly as possible. Now, clearly, A nor B could not be our answers, because we would have to go and multiply by the conjugate, and your answer definitely would not look something like these. So from this, we can see that the answer is either C or D. Now, since we have a negative here, and the 5 is greater than the 3, and the 5 is negative, I must have a negative in my answer. So the answer is clearly C. So guys, thank you so much and continue practicing. Okay, thank you guys for tuning in. This wraps up our video for today. Remember to like, subscribe, and share. This is Math Major Minor.